Assalamu alaikum wa rahmatullah. This lecture basically I'm going to cover the next chapter, chapter 9, relational database design by ER and extended ER to relational mapping. So let's look at what topics are in this chapter. Let me maximize my screen and share my screen with you. Okay, all right. So you are looking at chapter 9. In chapter 7, we discussed and studied relational database design by ER, entity relationship modeling. And in chapter 8, some extended notations and techniques for creating designs based on extended ER models. And now we will look at how we can use this entity relationship modeling or diagrams and convert them into a relational model and convert them into a database design, which we are going to do in our database of choice, for instance, Oracle or MySQL or SQL Server. So in the chapter, the main things that we are going to look at, number one is the schema mapping. So in this, we will be creating logical database design from ER to relational mapping algorithm. So there are certain steps. We'll go through those steps one by one. There are 7 steps that you may use to convert an ER into a logical or database design. And then there are model constructs for extended ER, entity relationship modeling. So first of all, as we know, and we have already discussed, the database designers, they use ER and ER modeling techniques, conceptual techniques, to produce a conceptual design, to produce a conceptual model. Then that conceptual model is mapped into database design, conceptual database design. Let's look at this mini world case that we looked at previously as well in one of the chapters in databases. So if we are looking at a mini world means the scenario for which we are creating a database. For instance, if you are creating a database for a retail store or for a university, then that would be your mini world. So you have requirements, you collect those requirements and analyze those, and based on that, you create a conceptual model. So that conceptual model is your, for instance, ER diagram or ER modeling. And based on this conceptual design, then you create the database mapping, database designing. And once you have that mapping, then internally a physical design is being created. On the left side, from your requirements, you have functional requirements, and those functional requirements are analyzed and then added into the whole bigger picture of that application. So in this mapping exercise, we will look at how we are using these steps. So 7 steps. The first step is basically mapping entities, entity types or entities, only those which are strong entities, and we convert them into tables or relations. In steps 2, we look at weak entities, and we will look at and see how those weak entities are translated or mapped into database design. Step 3 and 4 and 5 are concerned with relationships. We, as you know, with binary relationships, we have cardinality ratios, one-to-one relationship and one-to-many and many-to-many relationships. And in step 6, we map and look at how we deal with multi-valued attributes. And in step 7, mapping of an array relationship where we have more than 2 entities involved in a relationship. Looking at our company database that we have been working through in this book, in which we have entities, employee, department, project, dependent, so all those entities, and then we have relationships like works for, manages, controls, works on, supervision. So here is how we will map things. Now, step 1, remember step 1 is the regular entity types and converting them into relations or tables. So creating tables based on all the entities that we have in our conceptual model. Now, all the attributes, simple attributes, those attributes will become attributes of this table or this relation. And the key attribute which we have defined already in the diagram, we will use it as a primary key of that relation. And if there are more than one keys for uniqueness, then we use that composite key together to form the primary key. So in our example, we will have now relations or tables for employee, for department, for project. Now, dependent is a weak entity. So in the next step, we will look at how we are going to address that. And in each of these relations or tables, employee, department, and project, we will add attributes that we have identified in our ER diagram. So here it goes. Employee has first name, middle initial, last name, SSN, birth date, address, sex, salary. Department similarly has D name, D number. Project has P name, P number, P location. So after step 1, we will have this A. So we will have 3 relations or tables. And then their primary keys defined. In step 2, we map weak entity types. So in weak entity types, if you recall, we do not have a primary key, basically. So a weak entity lacks primary key itself, but it has a sort of uniqueness if we combine it with the primary key of the parent table, the relating table where this weak entity is relating to. So in this case, what we will do is we will take the primary key of the owner table and then combine it with the partial key that is in the weak entity, and together they provide the primary key for this weak entity, or then which will become a table. So this creating this relation dependent is basically step which correspond to the weak entity type dependent. So in this dependent table, we will have the primary key, which is combination of SSN of the employee and the name of the dependent. So those together become key for the dependent table. So this is how we map weak entities. Now next, mapping relationships. Now we have already 4 tables. Now we will look at relationships. There are, as we already learned, that there are 3 types of relations according to cardinality. There are one-to-one relationships, there are one-to-many relationships, and then there are many-to-many relationships. So if we, in step 3, we take one-to-one relationships and we convert them into database design, there are 3 approaches. One approach is to take primary key of one side and put it as a foreign key on the other side. So in any binary relation, we have 2 entity types, which will become 2 tables. So we take one primary key from one table and put it as foreign key in the other table. Now the rule is, it is better to choose an entity type which has total participation and then use that in terms of choosing to add foreign key. For instance, let's look at our example. So our example has, there is a relationship between a department and employees. So if we look at this relationship has one-to-one relation. So a department has only one manager, and a manager only manages one department. So there is a one-to-one relationship between employee and between so an employee can only manage one department, and a department can only be managed by one manager. So in this one-to-one relationship, now if you look at the participation level, from the department side, the participation is full participation or total participation, whereas from the employee side, it is a partial participation. How? Because a department, each and every department must have a manager. So this is a total participation definition. From the employee side, each employee, we cannot say that each employee must be a manager, because there will be employees that are not managers. There are some employees who are going to be managers, but not every employee is a manager, is managing a department. So this way, the participation level is not total from the employee side. So it's better in this case, in department, we put the foreign key of the employee table. So employee table has primary key of SSN, department table has manager as a foreign key. So this is we do a key approach. Then there is another approach. In this approach, we can combine those 2 tables. And combining table is only possible when the participation is total from both sides. So take an example of, let's say, students and their LMS accounts. So if we define this relationship, we can see that one student will have a particular specific LMS account, and from the LMS account side, we can say that each LMS account is associated with one and only one student. So there is one-to-one relationship. Now, participation level, if you think of student, so a student must have an LMS account. So every student will have an LMS account. There is a total participation from the student side. Now, from the LMS side, if you think about it, then you can say that every LMS account is associated with a student. So there is a total participation from LMS account side as well. So this way we have one-to-one relationship and the participation is total on both sides. So we can, if in such case, we can merge that relation into one relation, into one table. There is another approach, which is cross-reference approach or relation approach. In that option, what we do is we create a third table in between those tables, and we put primary key of both tables in the middle table as foreign keys. So both primary keys will appear in this middle table as foreign keys. So this is how we can deal with that. So here, if we look at this diagram, employee and department, now in this case, we have adopted the first approach. We have taken the foreign key of one side, the primary key of one side, which is the employee side, and put it in the department table as a foreign key. And in this case, we already discussed that the participation from employee side was not total. So that's why we took employee primary key and put it in department as a foreign key. Now, next mapping is one-to-many relationship mapping. So in one-to-many relationship mapping, how we do it is basically we take the primary key of the entity or table on the one side and put it as a foreign key in the many side table. So for instance, employee and department. So employee works for one department, but a department will have many employees. So there is a one-to-many relationship. So in this case, one side is, so we take the primary key from the department side and then we put it as a foreign key in the employee relationship as D number. So this is the case in one-to-many relationships. We can also use cross-reference in this option where we create a middle table and then put primary keys of both relations as foreign keys in this cross-reference table. My sharing. Okay, so the now mapping of binary relation type many to many and how we are going to deal with those relationships which are many to many. So for many to many, what we do is we create a middle table or a new relation, and this new relation or table contains foreign key, primary key of both of those relations that already exist and put them as primary keys, as foreign keys in this new table. So for example, the many-to-many relationship type works on, which is employee and project. So we have this relationship where we can say that employee can be working on many projects. So that is many side. And then if we look at project side, we can say that on one project there may be many employees that are working. So this becomes a many-to-many relationship. So in this case, we create a new table works on. We take employee SSN number and we take project number and put them as foreign keys in this works on table. Also, we add any attributes that are associated with this relation, and we put them in that new table. So it becomes our works on is our new table. So just to summarize how we did those steps, how we took care of one-to-one, one-to-many, and many-to-many relationships. Now, step 6. So in step 6, we look at multi-valued attributes. For example, department locations. So department location could be more than one. So this is a multi-valued attribute. So for this case, what we do is we create a new relation. So this new relation will include an attribute corresponding to this attribute plus the primary key of that table which already is there. So we add a new table, we put the primary key of that table as a foreign key in this table, and then we add attributes in that table as well. So deal equation is such a case. Now, so far we have talked about binary relationships in which there were only two entity types involved. But what if there are more than two entities involved within a particular relation? So n-array relationships, which we saw an example where we have a supplier which is supplying a part for a specific project. So we have this three-way relationships in which three entity types are involved. So in order to resolve this or map this, what we will do is we will create a new table, a new relation, in which we put the primary keys of these three tables as foreign keys, and then put this if you look at this supplier table, you can see supplier name, project name, part number, and quantity. So this is how we map it. So so our basic mapping basics for ER is done in these 7 steps. If you look at ER model versus relational model, how we are basically translating or mapping those. So every entity type in ER model become an entity relation. So it becomes a table in relational model. Every one-to-one and one-to-many relation types, we can use foreign keys to address these type of relations. So we are not adding any new table in this case. For many-to-many relationship types, we are creating a new relation and then using 2 foreign keys to address those. In n-array relationship types, we create a new relation and then use n foreign keys in that new relation. Simple attributes become attributes in relational model. Composite attribute, they become set of simple component attributes. Multi-valued attributes are addressed by basically creating a new relation and a foreign key in that relation. and value set is our domain, and key attribute becomes primary key. So this is how mapping is done in relational model. There are other constructs, as you know, in extended ER, and those constructs can be mapped using step step 8 and step 9 to map them. Step A is about mapping specialization and generalization subclasses. And step 9 is mapping categories, union types. So this is how we deal with. In step 8, what we do is we convert each specialization with M subclasses. So if there are specializations in that, we create subclasses S1, S2, Sm, and a generalized superclass, where the attributes of that superclass are K, A1, A2, A3 to AN, and K is the primary key into this relational schema. So we have 4 options. We can use one of those 4 options to map specialization or generalization. Option 8A is we create multiple relations, superclass and subclasses. 8B is we create multiple relations, subclass relations only. We do not create any superclass. In 8C, we create a single relation with one key attribute. And 8D is single relation with multiple type attributes. So this is how we can address basically specialization and generalization modeling. So if we have here, let's take an example of employee. So if we have an employee, we can create 3 subtables. We can create a relation secretary table, we can create a technician table or an engineer table, and then put SSN as a foreign key there, and then attributes that are associated with that particular subclass. In cars example, what we can do is we can use vehicle ID and then all that information into 2 attributes. So in vehicle, we have vehicle ID, price, license plate number, and in car and truck, we have. So these all examples are there to provide you more details about how these specializations can be, or generalization can be used. So if you are a person, then employee, student, alumnus, so all those can be translated into relations, and then using foreign keys we can address those. Mapping of union types, the categories. So for mapping a category whose superclasses have different keys, we can create new artificial keys or surrogate keys. So in relation, let's look at this example. In relation, owner, owner corresponds to the owner category. So the primary key of the owner relation is the surrogate key, which we call owner ID. So unique IDs of owner ID can be created by the system. So for instance, auto IDs that can be generated for object IDs in object databases. So it is always useful to add an attribute owner type to owner relation in such a case that if owner is a bank or a company or the person, we can use that. So here, if you look at, we have a category owner, and then that owner ID goes into the person. In bank, we have owner ID. In company, we have owner ID. Similarly, if you look at in vehicle, we have vehicle ID. And in truck, we have vehicle ID. In car, we have vehicle ID. And in owns, we have owner ID and vehicle ID. So this is how we map this extended ER concepts into relational schema. So this was a brief overview of this chapter. This is a shorter chapter and much straightforward. Hopefully you won't have any difficulty in understanding these concepts, but we will discuss them in our class next time we meet. Inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.